does anyone, let's review a bit. Let's just take a little bit of a moment to review. You have a machine, it's a PG Book VM 2020. And in your solution, you're going to be working a lot of different things. And so we wanted to show you in our last session how best to prepare the environment. And we said that one of the things you should do is when you're on this screen, my PG Book isn't running. What's the best way to start the machine? There's an option you should engage. Anyone? Should I just click this?
No, detachable start.
Yes, you want to use the pull down and select detachable start, especially if you're on a laptop. And so what that's going to do is it's going to start up the process. And then I'd like to ask you a couple of other quick questions just to make sure we hit those points really well. And by the way, I did find where exactly the font size and color options are hidden. They're in a slightly different place than other versions of Linux and other previous versions of Ubuntu. So I'm going to go ahead and close these things while it's loading. And while my virtual machine is loading up, what I'd like to do is take a moment to just dig into these assignments. So inside the 2.1 assignment, if you open up the folder, you'll see the actual assignment where you validate that you have access to Access. Now, Access is the name of a database program that's part of Microsoft Office 365. And you can download Office 365 from the My Campus portal if you go into the Office 365. But what happens if you're a Mac user and you download Office 365 on your Mac? It doesn't work the same way. And there's actually a workaround. So you can set up Access for Mac users. You can get into the Microsoft downloads and they may still have a version of Access as a development environment. So you can build database solutions using Access. And so this option is here for people using a Mac. I just wanted to share that with you. Any questions on the 2.1 assignment? So the 2.2 assignment is about automating data work in Excel. And so after you've proven that you either already have a version of Access on your system or you've acquired it, you're going to open up Excel and you'll work with this one. There's a PDF that explains how to do things, and there's a link in there that will show you a video on what to do to build this. Both of these files are templates, and what's going to happen is that you're going to walk through an activity where you learn how to simulate changes in the wind velocity using the formula for kinetic energy. And then you're going to use a feature called object linking and embedding in Excel and open up a Word document. And then after the chart is created with the formula, you're going to paste the chart into the Word document. And if you do it correctly, object linking and embedding means you can go back to the Excel spreadsheet, change the numbers, those will update, then the chart will update, then inside Word, and inside a Word document where the chart is, it'll magically transform the Word document, which is really pretty cool. And so this is another way to automate the work of your data. That's due this Saturday. When you see just a day, that means you have until 11:59 p.m., okay? So you have through the end of this week to finish 2.1 and 2.2. you have a longer period of time to work through the CLI essentials and the solution before we take the assessment. So as soon as we have some students that we start to get into next week, we'll make the Module 2 assessment available. Remember that you can still retake the Module 1 assessment for the final attempt, right? After you reconcile. I'd like to take a minute just to look at the solution. So there's a PDF and it walks you through what to do and how to do. But there's a coolness factor to this because basically you're going to walk through the tasks, and some of the tasks have more than one part. Does everybody see my screen?
Yes.
Okay, so you'll notice that task 1 will ask you to do a certain thing to capture the screen. And in just a moment, I'm going to show you how to capture the screen for the entire virtual machine and then paste it into a Word document, right? So there's kind of a trick. If you use the print screen key inside the virtual machine, it will capture the screen, but it'll store the image inside the virtual machine. And then you're in Linux, and the big challenge is, okay, what do I do to get the image of the desktop in Linux back onto my Windows machine so I can submit? That's what we'll show you in just a minute. So there is a walkthrough, and the video takes you step by step to task 1, and then there's a multi-part task 2. There's 2A, 2B, 3A. So task 3 is 2 parts as well. Task 4 is 2 parts, 3 parts. Task 4 has 3 parts, 4A, 4B, and 4C. And each of those screen captures is exactly what your result should be on your screen. Now, I want you to notice something here. This is really important. My screen image shows T. Kentop. Your screen image should show your first initial and your last name. What does it mean if a student pastes their result in and it shows T. Kentop instead of their name? What is that proof of? Anyone?
Plagiarism?
Well, basically they cheated, right? They used my image. So yeah, I just thought I would mention that because that's actually happened. People have turned it in, and I've said, you did this on your machine and you follow the directions in the video? And they're like, yeah. I said, well, in the video, you're supposed to use your own name when you're doing this. Remember, for the solution, you're using your own name. In another case, a student actually followed the video part by part or task by task, but they didn't use their own name. They said, I haven't cheated, honest, my virtual machine has the same thing. They followed, but they put my name in instead of theirs because they were following each step so precisely they didn't hear the part where somebody said, yeah, don't use Professor Kentop's last name and first initial, right? Any questions about, so you have a way to check your answers, right? Your answers should look just like this. And what you'll find is that the screen image doesn't look quite like this. And that's where the real estate, that's where the font size, that's where all the other stuff we were sharing in our last session comes into play. I get a lot of emails on this particular module where students will state, Professor K, my screen doesn't look anything like this. Now, what if you're on a Mac? You can actually do some of this on the Mac instead of doing it on your virtual machine. And there are OS X terminal counterparts to the same Linux command in a Mac environment. You just got to go to Google and look them up. Sometimes the commands don't exactly work, but one of the ways you can get your Mac, do we have any Mac users with us today? Is there anybody that's using a Mac?
Yeah.
Okay.
Yeah.
Oh, so this is really cool. Omari, yeah?
Mm-hmm.
Yeah, so Omari, when you take your Mac, what you do is you go into the users in settings and you create a PG book login and use the PG book password. And then that way, much of those same commands will work in the same manner. That's just a little tip or a little trick. So on your Mac, you can have more than one login. I don't know if you know this, but on your Mac OS X computers, you can have your own, but then you can support many other users. So you can simply set up a PG book user in lowercase with the same passwords, PG book. And then that way, when the textbook examples are shown, then you'll have more similarities. There will be still some differences because the Mac terminal is a little different. Are there any questions about what's expected for the solution? I just want to go back one level, and I want to make sure that if I go into here, the links still work. Or the, oh, wait a minute. All right, so there will be a YouTube video that you can watch and follow along. So here, when it says solution task walkthroughs, does everybody see this?
Yes.
Yeah.
So the PDF shows you screen examples of what your results should look like. But this is actually a YouTube link for each step, right? Section 1, section 2, 3, 4. Now remember that some of those tasks or sections, they have more than one part. So you're going to be turning in, when you watch section 4, you're actually watching task 4A, task 4B, task 4C. I hope that's clear. And so what you see here is going to track with what you see on the other samples. So that way, you know, you can kind of look on this screen, look on yours, and you can say, oh, okay, that's really cool. It works just fine. Now, let's go back to our terminal. Based on what I've presented, the information that's been shared, does anyone have any observations or comments at this time? So it would be great if you had your virtual machine open and you were doing as I'm doing while I'm doing it. And then if you get a different result, then we can share a screen and we can explore together what the differences are, okay? Remember that one of the things you want to do before you start your virtual machine every single time is update Windows, update the drivers, then update VirtualBox, right? If there are updates with VirtualBox, and here we're seeing, no, there's nothing to update. If it says, oh, there's an update, then you run the update. It's going to say, oh, the extensions are different. So you got to go out to Oracle and get the extensions. Once you have the extensions and you log in here, you're going to want to insert the guest edition CD image and run that update. And then you're also going to want to get on the virtual machine and run a command to update the virtual machine. So that seems like a lot of overhead, but if you run into problems when you're doing this, that's the key to getting your virtual machine to working in a smooth, fast, and hot way again. So once again, if you run into problems with your virtual machine and the screen isn't working and the stuff isn't right, walk through that same process I just explained. So what I'd like to do is open up PG Book using the PG Book password. I'll just close this for now. I did change the setting in here for the display so I can run a bigger screen if I want to. I could go to View and say Scaled Mode or seamless mode. If you go seamless mode, what that does is it puts the applications on your Windows screen or in here on your desktop. So that's kind of weird. Just thought I'd explain that. If you use adjust window size, you should be able to drag and drop and it'll resize automatically. You could go full screen. Remember that if you go full screen and you have to get your screen back, it's going to prompt you and it's going to say, hey, you have to be able to press this post key and the letter F to come back out of full screen. Otherwise, you'll lose your way. You won't be able to see Windows desktop. And then I'll get a call in the middle of the night. Somebody will say, Professor Kentop, you ruined my machine because now all I have is my virtual machine on the desktop screen. I can't get to my desktop or my start menu in Windows. Well, I'll ask you, what's the host key? And here's where it tells you it's either the right CTRL key on your keyboard or it's the left CTRL key on the keyboard. So I'm going to go ahead and switch. And now my big bad Windows computer display only shows my big bad Linux, my Unix, Ubuntu, my Ubuntu 1604 display, right? I'm going to go ahead and hit the terminal option. And I wanted to share this with you. I was kind of fumbling around in our last class, trying to find where the option is to increase the size of this. And it was actually right there all along. It just didn't appear correctly. So can everybody see the preferences option? No. It's the profile. It's the terminal profile, right? So if I go into a new profile, oh, yeah, this is it right here. So the key to getting the font changed is to open up profile, not preferences. In some virtual machines, it's the preferences option. And on this screen, this is where I was. So you have to actually select this last option that says custom font. And the trick to it is to select this button. And when you select this button, you can basically like make it bigger. I'm going to make it 16. When I select it, now that's the size of what's going to appear in here. And then I can change the colors. So the text and background colors. I want, or let's say use transparent background. Basically, one of the best things you can do is to make the fonts more like a yellow or a green. They show out a lot better. So right here it says green on black, but you could change it by unchecking the box and use white on black, gray on black, black on light yellow. So that's kind of interesting. Do that. So the images should be larger. When I did this yesterday, it finally got bigger. Oh, so this is the new profile. I'll name this big letter. Whoops, sorry. I'll increase the width and the depth of this. So I'm going to increase this to like 120. And I'll make this 36. And I'll go ahead and use a custom font. And I'll use a bigger Yeah, I didn't actually apply it before I left. I'll do select and then close. And there we go. Kind of bumped up a little bit. The screen size changed just a little bit. Anyway, you can noodle with that and get different results. Does anyone remember what the command is to update the software catalog on this virtual machine and then upgrade the software on this virtual machine? That's your hint. Does anyone remember the two-part command to update the software and Linux catalogs, and then to use those updated catalogs to upgrade the applications and operating system?
Isn't it get app update and then and upgrade?
That's very close. It's the other way around. So apt get, and then update, and then at, and then apt get upgrade. Now, when I try to run this, it's not going to work very well because I have a $sign prompt. Can anybody tell me why my command isn't going to run like it's supposed to? What do I need to do to this first?
You need to enter it in the super user.
Right, super user. I'm going to use sudo or sudo super user, SU. I'm going to put in the PG book password again. Now I have a pound prompt. Now I can type in apt-get update and apt-get upgrade. That's how I know that it's doing something. And notice again that the lines get funky. So in your solution, when it's walking you through that, it's going to tell you that you should stretch this out. The wider you go, the cleaner the output looks. Right? So if you get a really long screen output like this one here, the longer you go, the nicer the screen looks. It says some index files failed to load. I'm going to hit the up arrow key and run it again. See if that'll help. There is an option in here where you can go into here. And I think it's a graphical based update option. You know, Ubuntu software. So you can update your software in other ways, but the idea is we want to learn the terminal prompt. Based on what we've shared, does anyone have any comments or questions? So I'm going to use my right CTRL key and the F key. And now I'm back to a regular screen mode. Let's see if I can do something like this. There we go. That's going to help a little bit. So let's review some of our Linux commands. The other YouTube video and reference called Linux Essentials, that's going to be a really important thing to take a look at and follow. Automate a series of repetitive tasks using a shell script with Python programs. That's a part of the solution. So when you walk through the solution, it'll show you how to use Python and how to use each of these commands. So here's a hint for you. If the Linux command is in a student learning objective, you know there's going to be questions about it on the assessment, right? So here is something that I want to emphasize. We're talking about essential data tasks. Which view, so this is from the assignment, and I have a question to ask you. which arrangement of numbers is simpler and easier to follow? The arrangement on the left or the arrangement on the right?
Left.
Well, the left one includes more detail, but do you notice it repeats the same detail over and over again? Right? So what happens when you try to chart this? If you try to create a chart by dragging on this and then selecting a chart, it's messy. You have all these extra lines and they're straight lines. The same numbers are there all the time. But if I know that every number in the coefficient column, every number in the mass column, every number in the increase factor column, factor of increase, right? That's a 25%. So when you see 25% factor of increase in a scenario, you're going to use a constant 1.25. So if you take a number and multiply it by 1.25, it increases by 25%. Let's try that on for size. If I have 100 and I increase it by 25%, what's the number I should get back? Anyone? You have any math whizzes in the audience? What's 25% of 100? What's 1/4 of 100? I'm trying to make this easy. It's not a trick question.
25. So you get 125.
Yeah, it's 25. So if I want to increase the number, the base number 100 by 25%, if I multiply by 1.25, whoops, I'm sorry. I take 100 and I multiply by 1.25, that's going to be the same as increasing the number by 25%. I get the answer 125. So 25% of 100 is 25. And then if I want to increase the number 100 by 25%, I know the end result would have to be 125. And so on, right? So that's what this factor is. When we're talking about factors, we want to be able to increase, we want to be able to increase the wind speed. So in our kinetic energy assignment, the increase factor lets you, with a single number, increase all the wind speeds by 25% or 50% or 75% or 300%. Because all you do is change the one number. There is one thing that's worth looking at though, and this is one thing I really want to stress when it comes to spreadsheets. You don't want to repeat the same number over and over and over again, because visually that gets very busy and it's harder to pick out the trend in the columns that don't repeat. But if you have columns here and you have all of the constants in one place to the left and near the top, then if you have a series of numbers that increases in two adjacent columns, that's a lot easier to pick up on. It's easier to read. And if you have a sensible title, when you make a chart, all you're going to do is drag and drop and then go to the chart option. So I'm going to go ahead and kind of bounce back and forth and walk through a bit of the steps live in this class and show you how this works in Excel. So let's open up Excel. And then after this Excel example, we'll take a short break and we'll jump back into Linux again. Okay. I'm going to get a blank workbook and I'll make the screen really big. Okay. Everybody with me?
Yes.
So I'm going to take these labels and I'm going to put those into the cells in the same manner. So let's see, that's 1, 2, 3, 4. Let's make it even bigger. So 1, 2, 3, 4. I'll put increasing velocity and change in kinetic E for kinetic energy. Increasing velocity. And then right here, I'm going to put, actually, I think what I'm going to do is this. I'm going to merge the cell. I'm going to put in increasing velocity. What it should do is stuff both of those words in one place. Now, one of the things I want to do is format this so that it puts increasing on the top and velocity on the bottom. That's easy to do if I go to the page layout function. If I select this, I can say wrap text, and there you have it, increasing velocity. Did everybody see what I did right there? Wrap text. Let's do the same thing here. So I want one phrase, increasing velocity, to be the label right here. And I want these two cells, so I combine them. Let's go back. Change in kinetic E. I'm going to put this together. I'll type in change in kinetic E. I'll click here and wrap text. So now I have the two labels, right? I'm going to put coefficient, factor of increase, and constant mass. Now, I combined the cells here, so when I make the graph, it'll read increasing velocity as opposed to change in kinetic energy. But for the constants, I don't have to combine the cells. I can just use the factor of in one label and then increase as the next. So I'm going to come down and put coefficient. Is that where this is? Coefficient. I think that's right. Yes. And then it's 0.5. So I'm going to put that in there. And then how many spaces do I skip? One space, and then I have factor of increase. Factor of increase. And I'll skip a space. And then I'll say constant mass kg in kilograms. Everybody with me so far?
Mm-hmm.
Oops. That's big.
All right, boy.
Are we there? Oh, so the factor of increase has actually got a space underneath the number. That's not a problem. I can basically take this, I can cut it, and then I can paste it down to here. Now I've moved it a space. I'm going to put 1.25 like I had there. And for constant mass, I'm going to use 5 kilograms. Go ahead. Did you have a question?
I think they did. Yeah.
Was there a question? Hey, Omari, I'm going to mute you because you're talking into the class, okay? So what we want to do is use the power of the spreadsheet to create a progression of increases I want to use this factor of increase, so I want you to see that if I have 20 and I increase it by 25%, the next one is 25%. But if I take 25% and increase 25 by 25%, the next number is 31. If I take 31 and increase by 5%, I get 39. So the goal here is to use the power of the spreadsheet to repeat formulas, but I don't want to have to type them in all the time. When you're entering a formula in Excel, if you start with 20, like we did, and by the way, I'm gonna do this to keep things simple. I'll center it. I'll center this and this and this. I'm also gonna make this bold and this bold, just so it stands out different, right? I want it to be bolder and this to be bold. So now it's kind of weird looking because it's off the cell. All I have to do is put my pointer until it turns into the divider and double click, and it'll kind of open that up, right? And then I can hit wrap text again or leave it like that. All right, so I want to use the magic of this spreadsheet to repeat formulas all the way down the column, and I want to use this to create the next higher number that's 25% higher and put it right here. So I'm going to build a simple formula by selecting this cell because that's where I want it to go. And I'm going to start the formula with the equal symbol. So it says, I'm going to say equals this, and then I'll use the asterisk for multiply, multiplied by this. And when I hit enter, the formula is going to create a calculation between the value in here, C3, column C, row 3, and the factor of increase, which is 1.25 in A8. Now, if I try to fill this down in a hurry and replicate this, it's going to look up to the previous cell. But it's also going to look down. As I go down this way, it's going to look down. Oh, there's a label here. There's no number here. It's going to look down. That's a different number. It's going to look down. So as I try to fill down, Excel likes to repeat. If you do a copy, 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 paste, paste, paste all the way down, this formula is taking the cell above it and multiplying it by A8. So if I do this and I copy it, and then I paste it in here, I don't get a good answer. And the reason I don't get a good answer is because it looks to the number above, C4, that's good. And then it looks to A9. I don't have anything in A9. So how do I get the formula so that it always looks here as I'm filling it down the screen? There's a really cool trick in Microsoft Excel. You anchor the cell in the formula by putting a $sign in front of the column letter and a $sign in front of the number for the row. So here's how it looks. I'm going to recorrect this. Well, actually, I'm going to go back up to here. And what I want to do is put an anchor for A8. So as I fill down the screen with copy, paste, copy, paste, copy, paste, it's always going to look at this instead of looking down each one along with these as I calculate down with each one. So Excel is sort of semi-intelligent. It knows that if you're going to be repeating the same formula all the way down the screen, if there are relative references to left and right or above and below, if you repeat the same formula by copying and pasting, it's going to look to the same relative positions of cells, right? So what I'll do now is I'll put a $sign in front of the A and a $sign in front of the 8. So I'm pinning down the column and the row. When I hit enter, right, it is looking for the value in C3, and it's multiplying it times A8. So 20 times this should equal 25. Now, for some reason that didn't go. So I'm gonna back up here and re-enter the formula. So this value is going to be equal to 20 times this value. But before I hit enter, I'm going to put a $sign here and a $sign here. Now, if I'm correct, I'll see 25. And I see 25. The $sign didn't change the way the reference works for the cell. The cell reference is still A8. But when I do this and I copy it and I paste it into here, and then I copy it and I paste it into here, and then I copy this and I paste it into here, then it's going to increase the value by 25%. Now, one of the things that you see in your study guide is that the numbers here increase, but they don't show the decimal places. So I want to see if I'm getting the right progression here. What I'll do in my spreadsheet is I'm going to change this, and I'll go ahead and, let's make it a little smaller. I'll reduce the number of decimal places so it's just whole numbers. So I'm showing 20, 25, 31, 39, 49. Is that what I'm showing in the study guide? 20, 25, 31, 39, 49. Yeah, the same thing. Now, how many of you want to sit there all day and copy and paste, copy and paste, copy and paste all the way down the screen? That kind of sucks. What you should do instead is use an option called fill down, and it's really cool. So what I'm going to do next is show you how that works. I'm going to recreate the formula, and then after the formula is recreated, I'm going to highlight down the screen, and I'll use the Alt key, the I key. I'll hold the Alt key down, press I. That'll insert, and then I use E for edit and D for down, and it'll fill that formula down everywhere it's highlighted. It's the coolest thing you've ever seen. So I'll say equals this cell times this cell, but I'll put that $sign in there like I said I was going to do, and put the next $sign in there. I'll hit enter. I know my formula is working good. I'll click on it. I see the formula I built here. Now I'm going to hold my mouse key down after I click on it and drag down. If I press the Alt key, now I can use the I key and then the Alt E I D. Hold on. Alt E, then press I D. Everybody see what happened there? So I pressed I and nothing happened, but then as soon as I pressed D, it's like, okay, it's filled down. The keystroke sequence again is the Alt key with E. After that's pressed, you tap I, so you let up on the Alt and E key. And after you've tapped I, you tap the D key. And if I look, I can see this formula. Watch what happens here when I use my down arrow key. So if I use my down arrow key here, and everybody look at this piece right here. As I do my arrow key here, you'll notice that it's looking to the row above. So I'm in C9 and it's taking what's in C8 and it's multiplying by this. This never changes, but this reference does. That's what's happening here. So once again, if you've done this correctly, you ought to be able to use the down key. And as you do this, you can see how the one reference changes. It keeps increasing. Now, here's the cool part about including this one number. Let's say I want to increase it by 50%. All I have to do is change this number to 1.5. Wow. I've increased the velocity by 50% each step down the screen. What if I want to do 75%? 1.75. Wow. So in just a few increases, I've got velocity in meters per second, and now I have 829,379 meters per second. So that just goes to show you what happens when you increase by 75% with each cycle, right? Now, to get the change in kinetic energy associated with the increase in velocity, I have to use the formula. So what I'm going to do is put the same formula in there. If I'm looking at my study guide, it'll show you the formula for kinetic energy, and that's, anybody know what the formula for kinetic energy is off the top of your head?
Mass times, can't remember.
It is mass
Mass
times,
times something.
it is mass times velocity, but the
Okay.
velocity is squared, and then there's a constant 1/2 in front of it. So 1/2 mv squared. Right? So, and that's in here somewhere. Let me see if I have it. Let's try to find this MV. Oh, no, it must be in the addendum or in one of the other, or it's in the assignment folder. It tells you. So if you go into the assignment folder, the extra information in the assignment folder will have that specific information in here, in here, in here. Oh, I'm sorry, that's 2.1. My bad, 2.2. So what you need to look at is in here and in here. It kind of explains all of that and how we're using kinetic energy to calculate the increase in kinetic energy. Now, one of the cool things about having a spreadsheet like this is you can save this one sheet and then flip it and increase the kinetic. You can increase the mass instead of velocity, and that has a dramatically different result. So in the formula for kinetic energy, 1/2 mass times velocity squared, what it literally means is every time the velocity is increasing, it's also squared. The velocity is squared. So if the speed of a hurricane doubles, did we talk about this before? Square functions? True or false? A car going twice as fast has twice as much kinetic energy. What's 2 squared? Anyone? Hello?
4.
It's 4, yes. What's 3 squared?
9.
Yes. What's 4 squared?
16.
It's 16, right? So every time you step up an increase in the velocity, if you double it, if you triple it, if you quadruple it, if you increase it, it's 4 times as bad, it's 9 times as bad, it's 16 times as bad. That's why Category 5 hurricanes are so bad. Is because kinetic energy, or the energy due to the speed of the storm or the wind, it's a doubling function. No, it's not a doubling function. There's a 1/2 coefficient there, so it's a halving. So you half a value of the mass, but you multiply it by the velocity squared. So to make the formula for kinetic energy, what I have to do is take this times this times this times this. When I times this twice on itself, that's the same as squaring. So how does that look? This equals 1/2 times the 5 kilograms times the velocity of 20 meters per second times the same cell, 20 meters per second. So by repeating the cell twice, that's the same as squaring the velocity. Does everybody see what I did there? For this formula, I want the coefficient and the constant mass as I cut down the screen with the fill. I want these numbers, these cell references, not to stay constant. So I'm going to take a $sign here and a $sign there. That anchors this coefficient. I'm going to take a $sign in front of the A and the 12 for this one. And I'm going to hit enter. And if I do that and I check my math, let's see, what's 1/2 times 5? That's 2.5 times 20 times 20. Let's do it with a calculator. I just want to make sure it's working. Everybody with me? 0.5
Yes.
times 5 times 20 times 20. Oh, what did I do? 0.5 times 5, it's 2.5, times 20 times 20. Okay, I got happy fingers there. So I get 1,000 joules of kinetic energy. Now what I'd like to do is use that formula and create a series all the way down the screen. So I'm going to do the same thing. I'll select this. There's my formula, big snarly formula. But I'll use my mouse to drag it down. And then I'll use that same magic keystroke combination, Alt-E. And then I'll let up on Alt-E. I'm going to tap letter I and letter D. Wow. So as the velocity increases so dramatically, it does it even more because it's multiplying by itself. I have a number so big, it has to use a different notation so that you can read the number. I'm going to go ahead and double click this so that you can just see the whole number. I probably have to do like, yeah, I can convert that, but basically, I'll tell you what, I'm just going to go ahead and delete these. I want this to look pretty. Okay, so I have whole numbers all the way down the screen. Now, if I want to create a chart, that's real easy. All I have to do is highlight the two titles for the series and then drag down. And then if I look at my Excel, there's an, let's do this again. Insert. I use the insert menu and now the ribbon changes. And I can choose a chart. I'm going to use a line chart. So I could click here and it would open up this whole section. I'm going to choose a line chart. Recommended charts. So this is a line chart. That's a scatter chart. That's a bar chart. Yeah, just a straight line, right? Not a scatter, but a straight line. I'll use a straight line. I can fill in the title after I'm finished, and it's gonna plop that chart right down on here. So I have to move it around a little bit on the screen. So I'll hit OK. And now I have a chart with a chart title. See there, it changed I think those are those natural base numbers, logarithm? I forget. You notice how dramatically the kinetic energy increases, right? So as the velocity increases, the change in kinetic energy is exponential. That's why the curve is so steep. We can call the chart title something about what this series is. So we want to choose a chart title that reflects what's going on here on the screen. And I can say something like, kinetic energy increase I lost my train of thought. Kinetic energy as velocity increases. There we go. Sorry about that. As velocity increases. So as the velocity increases, that's what happens to the kinetic energy. The velocity is the blue line, and you see the velocity compared to these numbers. These numbers are increasing so dramatically, you have this curve that kind of takes off like a rocket. The increasing velocity is on this scale is so small it looks like a straight line, but if you were to zoom in, you'd find out that this is actually increasing with these numbers. What I'd like to do is take a short pause, and then what we'll do is run back to the Linux machine and try out a few more commands. Does anyone have any questions about what we just shared with the kinetic energy and Excel? If you watch the videos for the assignment, it should be pretty straightforward. Now you're also going to take this result and then you're going to copy it and flip it so that the velocity remains constant and the mass increases. And when you build the formula here, you're going to do it differently. You're going to say 1/2 times the mass that increases times the velocity that's staying the same and times the velocity that's staying the same. So instead of saying constant mass, you're going to say constant velocity. You can change these things just by doing this. I'm going to copy this spreadsheet. I'm going to move it to the end. I'll create a copy. And now I have an identical spreadsheet, right? I'll say this one is velocity. So I'll rename it velocity. And I'll rename sheet 2 mass. So I know which factor is being increased, okay? So that's the whole point of changing the tab. Kind of reflects what's going on. To make this happen, I have to do constant velocity. Let's make our velocity 20. So the velocity is going to stay the same. The increasing mass, we'll make it a factor of 1.5, right? And we're going to have to change this. So kinetic energy as mass increases. And there's just one more problem. I have to change the formula. So I have this first part here. The mass is increasing by 50%. So 20 becomes 30, 30 becomes 45. That progression makes sense. But my formula here is wrong because it's based on the velocity calculation. I'm increasing the mass. I have to say equals 1/2 times, whoops, the mass times the velocity times the velocity again, right? If I hit enter, what I have to do is put a $sign on this and a $sign on this, okay? $sign here and $signs there. So I take this first formula, put a $sign there, a $sign there, and this is going to be increasing, so I want these numbers to change. I'm not going to put $signs here, but I'm going to put a $sign here, $sign there, $sign here, $sign there. When I hit enter, I should get the same number. Now when I do the fill down, with Alt EID, watch what happens to the numbers. Alt EID. Isn't that cool? So the mass stays, the mass increases, but the part of this formula that has to do with mass isn't squared by itself. It's the velocity that's squared by itself. So the formula is different. As I look down this screen, I see velocity times velocity, but it's this number right here. That never changes. It's only the increasing mass. This is easier to read. It means that if you increase the mass, you get an increase in kinetic energy, but not as dramatic as you do when you increase the velocity, okay? So as I look here and look here, I have two different results. It didn't take me long to do the second one, as long as I knew how to alter the formula. What you'll do is you can copy this chart into a Word document, and if you copy it the right way, instead of copy as a picture, you use copy. When you get into the Word document, that'll link the data and embed it inside the Word document. Now, what am I saying? I'll just open up a Word document and show you. Let's open up Word. I'll open up a blank document. I'm going to change the layout so that the margins are small or narrow. Then I'm going to change the orientation so it's landscape. I want to view it a whole page so that I can, one page, right? What I'm going to do is paste the first chart and then paste the second chart. But I'm going to use one of the features on paste. I go to here and I look at velocity. If I click this chart and then copy it without copying the picture. So if I use copy as a picture, it's only going to take a picture of this. If I use copy, it's getting all that data, all that stuff. And I want you to remember how the funky numbers are on the left column and the curve is steep. So I go into here. I'm going to use my paste option, and I can use paste special, right? Or I can hold my pointer over this. It says keep the source formatting and embed the workbook. So that's embedding the workbook. When I change the original data, this is embedded and it won't change. If I link the data, right? Keep the source formatting and link data. This is the one I want. I do this, you can see what happened to the numbers when I used the linking. Now I have my cursor here, so I'm going to put a few spaces in here. Now I have a way to post the second chart, and it's going to sit right next to this one. So I'll go into here and select mass. I'll click on this on the edge, on the border. I'll copy, but not the picture. I'll go back into the Word document and we'll paste linking and embedding. I'll keep the source formatting. Notice when I kept the source formatting for kinetic energy, it kept the same modified numbers because those numbers are so big. So you see the two different titles. Kinetic energy as velocity increases, kinetic energy as mass increases. And what happens if I decrease the increase factor on my kinetic energy? I can do this with velocity, and if I decrease this to, like, let's make it 10%. 1.1. Well, that's not really as dramatic, right? 10%. Well, let's make the increase in velocity 20%, 1.2. Well, that's a little more dramatic, right? Look at how the number of joules increases. What happens in my Word document? Oh, the funny numbers are gone. and the curve isn't as steep. Everybody see what happened there? In the mass chart, I'm going to change the factor and let's make it a factor of 300%. Right? We'll make it 3. So I'm increasing by 300%. If I increase the mass by 300%, I'm tripling it every time. That's an exponential increase. Now I see the curve again, right? But that's because I'm increasing the mass exponentially, and the kinetic energy does likewise. If I look at my Word document, now I see, oh, the kinetic energy isn't so dramatic when the velocity is increased slightly. But look at what happens here when I increase the mass. The cool part is you can automate the way that charts update when you recalculate on a spreadsheet. So I could say, well, let's make the factor just 200%. It's a factor of 2. No, I don't like that. I want to use 1.4. 40% increase. Well, now I have 1 million for the top number on my scale. Let's see if that changed in the Word document. Yes, I have 1 million in my Word document. This is called object linking and embedding. It's a way of automating the repetitive data calculations so that you can just recalculate and then the charts in a Word document where you're explaining the chart, it updates automatically as well. So if you have a report you have to write, the words in the Word document can be here, but the numerical elements can update through Excel on the back side with linking and embedding. I hope that explains everything in a slightly different manner than what's in the video. And when we return on Tuesday, we'll do a deep dive on the wonderful world of Linux commands. We'll get into the really cool stuff on the Linux side. This should get you to a good place where you can get the first 2 assignments done over the weekend and get started with the solution. So on Tuesday, we'll walk through the solution together. Any questions, or does anyone have any comments or observations you'd like to share based on the information we've provided today?
No.
All right. Well, have a great weekend. Thank you for joining us. This has been CSC 239. We'll see you on the other side.